In this video, we will cover the foundations of working and automating your working process with Truffle. Here is the demo folder we created in the previous video. It contains the pre-installed Truffle Mac project called MetaCoin. First, we will remove all of the files that are directly related to the project from our Truffle demo project. That means all of the files that are in the contracts folder, except for the migration.sol file, and all of the files in the test folder. Now we can start to create our own smart contracts. In Truffle, all smart contracts should be placed under the contracts folder. I will create a new file under the contracts folder, and I will name it demo.sol for solidity. In this file, I will write my smart contract. It will be a simple smart contract that will contain only one variable, which will be a public string called name. I will insert my name, Shlomi, into that variable. In order for Truffle to be able to deploy my smart contract, I need to make some changes to its migration folder. In the migration folder, under Deploy Contracts, I will see the following code. This code will tell Truffle what a migration or a deployment process should look like. This code will deploy the MetaCoin smart contracts that I have deleted earlier, so I can just clean it up here and make room for the smart contracts that I really care about. The first thing I need to do is to declare a JavaScript object that Truffle can use. Truffle defines this type of object, which are called artifacts, for working with smart contracts. I will declare my demo contract artifact at the top of the file by typing var demo equal artifacts require demo. Now that the demo artifact is defined, I can use the deploy method on the deployer in order to deploy that specific artifact. This is done by typing deployer.deploy demo. To make sure that my migration file is properly set, I will open another terminal window on which I will run my test RPC. Once test RPC is up and running, I will use the command truffle migrate from within my demo project directory. And now, as you can see, the demo smart contract was successfully compiled and deployed. Now we can move to the next stage, which is to create a test file. The smart contract demo is an extremely simple one. It contains only one variable, but in most cases it will be more complicated than that. That is why we want to have a way to check all the contract methods in a speedy and automated way, hence the test file. However, before we create our file, there is a simple library which I prefer to use whenever I create tests for my smart contracts, called Chai. This library will add a BDD style to my code, which basically makes it more readable. This library can be installed by typing npm install chai. Once installed, we can start create our test files. All test files in Truffle should be located under the test folder, and this is where I will create my test file. I will call mine o1test.js. Truffle calls these files in alphabetical order, so I like to name them with numbers to guarantee that the files will be called in their proper order. In this case, however, it won't make too much of a difference since we have only one test file. Now, before I start to write my test script, I will define two objects. The first one is the artifact of the smart contract demo that I want to test. I will declare it just the same way as I did in the migration file. var demo equal artifacts dot require demo. The second object is the expect method from the chai package I just installed. I will declare it in the same way all node packages are declared, using the require command, expect equal require chai dot expect. And now for the test itself. The tests in Truffle can be nested into three levels. Level are contract, describe, and it. Contract is the highest level, and this is the highest context for our smart contract. In here, I will check all the methods that are related to my smart contracts. To this context, I will also pass the accounts object, which isn't really necessary for the sake of this example, but it is a good practice to include it. It will give us easy access to all of the accounts that were created by the test RPC. Now, within the contract scope, I will nest my methods into describe and it. Please note that this distinction between describe and it isn't really that meaningful in terms of code execution. We are only using the distinction to have a better nested code, which will be easier to read and maintain. The first process I want to describe is the deployment itself. I will do so by typing describe deploy the demo smart contract, and then defining my function. In this function, it will be nested that will grab the instance of the smart contract that I will soon deploy. Now it is time to actually deploy the smart contract. We will do so by calling the method new on our Truffle demo artifact. Then we will take the results or the instance of that new method and store them into a global variable called demo contract. This will be the demo instance that we will use throughout the rest of our testing script. Notice that Truffle gives me a promise-like interface when creating test script. That is why I was allowed to use the then method instead of working with callback functions. This isn't a must, and anyone can choose their preferred method, but it's still a nice feature that Truffle provides, and I prefer it over the traditional callback function, and I tend to use it in my codes and tutorials. Now the next thing that I want to describe is the variables check. In this case, we only have one variable, so this process will be extremely short. But you can imagine how nesting these cases can be useful when working with more complex smart contracts. We will nest an it inside our second description that will check the result of the name variable. It should be Shlomi. So now we will call the name method, and don't forget that in Solidity, every public variable also gets a method with its name. So we will call this method. Once we have the results, we will check them with our expect object by claiming that we expect the results as a string to be equal Shlomi. The syntax for working with this expect object and BDD style is explained in greater detail on the chai.js website, and I encourage you to check it out at chai.js.com. Now my test file is complete, and I can now open another terminal window and type Truffle test. Truffle will now execute the test file and will show me the results for each test. I can also see that if I am expecting a different result, for example, if I will change my code to expect the name to be equal Shlomi Z, I will also receive an error message containing the cause of that error. All of this gives us great tools for debugging and assessing complex smart contracts.